Hello and welcome back to the Cloud Chronicles. Today we're going to be talking about Azure Storage beyond the managed disk. This goes back to a lot of early history of Azure, and it's going to be fun to talk about. And these are a lot of things that, if you're a database professional, you might not know about because they're different. I'm Joey D'Antoni. I'm Principal Cloud Architect at DesignMind. And like I say, we're going to be diving into Azure Storage Services with a focus on kind of developers and developer tools. And John, do you want to introduce yourself?
Sure. My name is John Morehouse. I'm a principal consultant with D'Antoni and Associates, and I love Blob Storage, Azure Storage.
Yeah, it's definitely something that, like in any cloud, storage is one of the first services that happened to exist. It's kind of funny because there are some parts of service storage that I don't think we either of us use that often in our jobs, like queue and table storage.
That's true.
I actually had to go back to 2017 to pull some slides, and we'll kind of talk about that. But Azure gives us a whole lot of different storage options. And one of the things I don't think people inherently know about when they build storage is that there is a storage account, especially if you're working on VMs and you're only using managed disk. There is a storage account that's behind all of your managed disk. You just don't see it. Back in the early days of Azure, when we created storage for a VM, we had to create it in a storage account and mount it to a VM that way, and it was painful. But like,
It was painful.
as you can see here, so we have data lake storage, which is effectively Blob storage. It's Blob storage with a hierarchical namespace on top. That means it has a Linux file system. It's a fancy way of saying it has a Linux file system on it and Linux permissions. Blob storage and data lake storage are effectively the same thing under the hood, just that namespace. File storage is a little bit different because it can present to an operating system. So typically you need some kind of thing that can talk to an API to write to blob storage, whether that's Spark, whether that's your own C# code, whether that's Azure Storage Explorer, SQL Server backup to URL. All of those things can talk to Blob, but you can't like map a drive to Blob storage. There are some third-party tools that'll do it. I think we did. Was it you who showed me the Reddit post, or I sent you the Reddit post about that guy who had data corruption?
I think you sent it to me because you look at Reddit more often than I do.
Yeah, yeah. Don't do that. So file storage it costs a lot more than Blob storage, but you do get that OS access. So it's designed to be kind of a replacement for a file server. Yeah, you've had customers use file storage, right?
Yeah, we actually had a customer who wanted to use file service because you can mount it like an SMB share, right? You can have a UNC path, and it's effectively like a NAS device in your local environment that you might have now. They were looking to use it for very large backups. I don't.
Yeah, that's right. I remember that.
Yeah, they were looking like big terabytes upon terabytes of data of SQL backups that you couldn't store in Blob storage natively. So they were looking for that Blob's file service as a replacement.
I don't remember why they couldn't, because it's like you can store 56 terabytes, I think, in Blob storage.
Not natively backing up from SQL, right? There's a 12 terabytes.
Oh yeah, it's 12. It's 12. I'm thinking something else.
It's 12 terabytes natively from SQL. So they were looking to get around that, and the only way we could effectively do that was to use file services from Azure Storage.
Yeah, that makes sense. Yeah, which the cost on that is
yes,
yeah, it's a lot. They were an enterprise there. I remember that.
Yeah.
The one of the other things, if you're testing file storage and you're trying to do it from your home lab, a lot of that uses port 443 over the internet by default. Like in an enterprise environment, you'd set up a VPN and stuff, and that's a nice topic because we're going to be doing a big series on networking. So if you're new to networking or you don't know a port from a plug, or we're gonna be doing kind of a John and I mapped it out, and it's going to be like a 10-part series on that.
Yeah, it's pretty big.
So it'll be pretty cool. But that by default just goes over the internet to port 443, and actually that. Let me bring up a slide. We can see we have blobs, tables, file shares, and queues. Each of those have their own namespace. So if we like map into Azure Blob Storage, and I look at a file, hopefully I have some JSON here, or I know I have a Parquet file. So like if I look at the properties of this Parquet file, Oh man, I used. Let me turn
Oh,
off.
you're masking it.
I,
You have a distinct URL to that blob.
yeah, that's what I was trying to
Yeah.
show. So we have a distinct URL path, and that URL path is. There's got to be some place they don't hide it. Let me just paste it into this text field where you can see. Uh, Data. It's going to be the storage account name, which is in this case API Builder Demo.blob.core.windows.net. If you're using file storage, it's going to be .file.core.windows.net, and likewise for queue and table, it's going to be queueandtable.windows.net. So just each storage type has its namespace, but you can have all of those things in a single storage account. There's no real penalty. In the earlier days of Azure, I think there were some tighter limitations on like how much storage you could have, how many files you could have, and there still are some, and they're pretty high. It's like 500 terabytes or something. How much you can put into a single storage account.
And it's probably worth noting that the URL that you showed has to be the prefix for the storage account has to be globally unique.
Correct.
Right? Because you go over that 443 port, which is publicly over the internet unless you do use. If we're going to talk about security, we're going to talk about private endpoints and securing that further. But that was always one of my gotchas, was because everybody wants production storage, so you have to name that sucker globally unique.
I have a client that's got like SQL West US backups. I was like, that's kind of cool.
Yeah.
But frankly, that namespace, even if you're global, and even if you're all locked down and all private link, it still goes to the same global DNS. So it has to be unique. The other kind of annoying thing is this is probably Linux or something somewhere under the hood, so it all has to be lowercase, and you can't have any characters. Yeah, no dashes or underscores as much as you'd like to have them. So that is something else to keep in mind. So the way things are priced, since it's storage, since we always like to talk a little bit about pricing.
Absolutely.
It's kind of interesting, and since this is going to be a little bit developer focused, let's talk through that. Let's talk about Blob storage. Go for it. You know the pricing model.
Yeah. So the price, I don't remember what the price is per gigabytes, but to create a storage account,
it's about $40 a terabyte.
40. Okay, so $40 a terabyte. To have a storage account just sitting there with nothing in it doesn't cost you anything. So you can create a storage account and not put anything in it and like reserve that globally unique name if you really needed to. But if you start to store blobs in there, as Joey said, it's about $40 per terabyte. You can do the math. Typically, we usually say that storage is cheap, and per gigabyte it is. You can put stuff in the blob storage containers in a storage account, and your overall cost is pretty minimal unless you are getting into the multi-terabyte size of storage. And then you might have to do something. Now,
forget about usage.
Well, and usage, right? Because and we have to talk about for pricing from the blob storage. There's different tiers, right? There's a hot tier that is easily accessible, that you can get access to very quickly, and then there are cool and colder and archive tiers that are designed to keep your blobs long term at a lower cost. The downside is that if you have stuff in the archive tier, it could take up to 14 hours to rehydrate that object if you want to pull it back out. So you have to balance that cost from availability. But it's a great place to store files. I love blob storage.
That's a really good intro to our next topic. Thank you.
You're welcome.
The other aspect of that cost, I mentioned usage, and if you're a DBA or you're used to working with database files that don't get, I don't want to say don't get touched, because when we're writing MDS and LDS, they get touched a lot. But if you're writing backups, you generally only write that file once. Hopefully you never read it, but maybe you read it 5 or 6 times if you're storing a dev. What I'm kind of talking about is, because those files are HTTP endpoints, we can use them to serve things like images. Every now and then you might notice, if you're on a restaurant website or something, they might store their menu as a PDF, and you'll notice it's got a blob.storage.windows.net URL path, or an Amazon S3 path. Each time those files get read, there's a read meter that's associated with that. And depending on your storage tier, like John mentioned, and we're going to talk here about tiers in a second, but like John mentioned, that storage tier, you get so many free reads, and in like hot you get more free reads than cold, and I think more than cool. I really don't know the difference between cool and cold. They introduced those and I was like, this is the dumbest naming convention, because like, who remembers cool versus cold? I'll explain archive too in a second. But the more you read those things past the free limit, you pay for it. So if you have like a website and you don't use a cache and you're constantly reading an image, or not a cache necessarily, but a content delivery network, which I guess is a type of cache.
It's cache.
Yeah, you're going to get nailed. So
Yep.
just pay attention, because you can have usage fees on storage. It's not something you think about so much in data world, but it is something you think about in like website world. So that's kind of where I was going with that. And it's kind of good. We're in this lifecycle management screen here, and I can add a rule. And I'll just call it demo rule. And I can say what type of blobs I want to apply it to. This does require Gen 2 storage account, so if you have a very old storage account, you may have to upgrade it. And then I can say if blobs were last modified 30 days, then delete the blob, or I can move it to one of those other cold storage. So cool storage is you want to keep on cool storage for at least 30 days. Cold is data you want to keep for at least 90 days. Archive storage is kind of interesting. John mentioned that. It's really cheap. It's like a penny a gig a month.
Super cheap. Super cheap.
So the way, tell me how you define it to clients. The way I define it is if some government agency says you have, or an auditing firm says you have to keep data, this is the service you want to use. If you actually need the data, you should never. If you need to retrieve the data, you should never use it.
So I usually I tell clients pretty much the similar concept. What I usually tell them is if you need the data back quickly, don't use cold and archive. The retrieval time to rehydrate the object is throttled. Like I said, the archive I think is up to 14 hours. Is what Microsoft says, is that it's going to take up to 14 hours to actually get that blob back off the media.
Yeah. So I don't know about cold.
Cold, I think it's not 14 hours, but it's it's degraded to some level.
I don't know. I don't actually know what they're doing with cold, but with
I'm not sure what they're doing with cold either.
With archive, it's on tape. So like the tape's literally archived. The metadata about your blob is online. So like you can see that you have the blob, but you can't retrieve the blob until
the contents.
Yeah. So basically, it gets rehydrated.
I do tell people that tape is still around, right? Yeah. You mentioned that archive is actually stored on tape media, so tape is not dead; it's still around.
Yeah, for sure. And that's that lifecycle management can let you do that kind of automatic tiering. Couple of risks with that you want to keep in mind. A good example of where you think you might want to use cool storage would be SQL backups, right? Because you're probably never going to read them, or maybe just read them a couple of times, and you're like, oh, it's cheaper. Well, if you delete those within 30 days, there's actually a penalty.
Yep.
So
absolutely correct.
In most cases, and honestly, the price difference between hot and cool isn't that much. It's like $10 a month. It's more that there's a huge difference with archive. So if you're not keeping the data longer than 30 days, you can set up an automated policy, but set up an automated policy to do hot, then delete.
And there's also a penalty with archive too. It's 6 months.
Yeah, with archive it's 6 months. And the other thing about archive is that you do have to pay, and like you can pay extra to get the data back rehydrated faster, but you do have to pay for that data. So that's something else to keep in mind, and it's pretty expensive. So don't put data in archive that you're anticipating needing. Put data in archive that like you might need if somebody comes asking for it, but like you don't want to plan on retrieving all of it. So let's talk about some other common developer scenarios. We talked a little bit about serving some static content, but have you seen integration with CI/CD or anything like that?
I have actually, and like one of the things I personally have looked at is using static websites, which uses things like GitHub, and you can automate that CI/CD build to store artifacts from that process into a blob storage or create HTML or Markdown files for your static website. So I'm actually seeing an uptick in organizations that are using like Azure DevOps with CI/CD pipelines, and they use blob storage to store those artifacts.
Yeah, I have a container app. It's that little VM sizes app.
Oh yeah.
Yeah, and it's an Azure container app, and those use file storage for your configuration file. So that's like the persistent storage for your container. So my configuration file is stored in file storage. It reads that on startup, and that's how that works. Kind of one of the other interesting things about this is the way security works. Security in storage has come a long way. Back in the early days, we only had storage account keys, which was like if you had a building and there was one lock to get in the building and you could get anywhere else in the building, that's what storage account keys do. So if you have a storage account key, which I don't really think anybody uses anymore, the only place that I know that still requests one, and I've yelled at them for this and they haven't fixed it, is if you're using Cloud Quorum and Windows Server failover cluster.
Yes, that's
what's,
right.
what's annoying is it does actually request it uses a shared access signature under the hood.
Oh, that I didn't know that.
Yeah, this is what they told me when I bitched them out. Uh, and they're like, well, we're using a shared access signature under the hood. It's like, no shit, dummies. Let the user request them. Shared access signatures also kind of suck too, because they're effectively just temporary passwords. Not even temporary, but like if somebody gets a SaaS token and it's valid, they can get. I mean, there are limitations around. You can put IP policy around them, but they're not good either. But they're what we have to use for a lot of things still. But there is a lot of Azure AD support in the last several years, or excuse me,
Yeah.
support. In the last few years, everything's moving to Intra. So my little app, everything authenticates into Blob storage. I have like automation writing in there, and it's authenticating as itself. And I have SQL database reading from there; it's authenticating as itself. And I have that web apps also reading as itself.
We should definitely do a video on Microsoft Intra.
Yeah, or
Security.
or that's going to be another one where we're going to have to do 12.
Yes. That'd be a great video to have though, because everything's talking to Intra now, right? You can
I mean,
manage identities, and I think that Microsoft has done a great job of bringing like the storage accounts forward in a lot of areas. I remember when you mentioned SaaS tokens, the shared access signatures. To do an access policy, you had to do it by code, and then they brought forth the ability to do it in the Azure portal itself, which I think is a great security feature.
Yeah, it was not. There are several. Like honestly, lifecycle management. When they introduced that screen I just showed, you used to have to handwrite that in JSON, and that was kind of painful.
Yeah, I remember that. I wrote some of that code. I know.
Yeah, let's talk a little bit more about file shares. I know we discussed them in the context of backups. This like the first kind of memory I have of file shares in Azure was, do you remember they had that Azure file sync thing? Do you know if that's, I don't even know if that's
I do remember that. That's still out there, if I remember correctly.
Yeah.
I would have to go Google it and look.
Yeah, it would sync your on-prem files to Azure and kind of get things going that way. I think the main use case I see customers doing with Azure Files is just doing file server replacement. Like you pay a little bit more for it, but you're not paying for compute. It's a little one thing. It's kind of expensive, but it's not as expensive. Amazon has FSX, which is their file share as a service offering, and it's freaking expensive. Like I did a storage test last year, and that's FSX is one of the ways you can cluster a SQL server. So I was using that, and I was shocked at how much it cost. But I think they actually stand up a file server for you, and that's part of the reason why it's so expensive.
Well, that would make sense.
Yeah. Presumably there's some kind of file share, but I don't know how that's implemented under the hood. There are kind of a lot of weird integrations with file storage. The biggest one and most common one is that it's kind of what Kubernetes mostly uses for storage. So you define those, in this case, not SMB, but NFS mounts, so like Linux mounts. And that's how you do, you present volumes and persisted volume claims in the Kubernetes and using AKS. Presumably you can, in Kubernetes, there's going to be a controller to connect to the storage. So like if you rolled your own Kubernetes in Azure because you hated yourself, you could potentially use file storage too, but it's what AKS uses. And just kind of like my little app, it just presents as a mount that shows up in the container. One of the things I like about containers is a lot of those concepts, like having a folder on my Mac, having a file share in the cloud, they all pretty much work the same way, no matter what my platform is. So that's something that's kind of nifty.
Yeah, we can talk about AKS as well.
Yeah. Yeah, I was in AKS. I'm actually the project I'm working on right now is using Amazon, so I was in it so I could compare it to EKS, and they are remarkably similar. The next two things we're going to talk about here are something like there's things that I haven't seen used in a while, but I think they're kind of interesting. One in particular, it's more of a pattern, and I think the pattern is still broadly implemented, but I don't think that many people are using Azure Storage for it, and that's going to be queue storage. And if you're not familiar with queue storage, uh, it's just a way of doing asynchronous processing. So we have queues and messages, and a queue can contain many messages, and the queue processes scope to the storage account. There's no limit on the number of messages stored in a queue. A message can be stored for up to a week, and the system will garbage collect messages that are older than a week old. And it can each queue can have metadata associated with them, which is in the form of key value pairs. And those messages can be up to 8K in size. To store larger data, you can store data in Azure Blob or table store, and then store the entity name in the message. And when you're putting a message into that queue store, the message data can be binary. So this is a common pattern we see, and here we see we have a partition name called queue name. But the reason why folks use queues, and this is I probably should have led with this slide before we went into the fundamentals, but it decouples different parts of the application. You're effectively, when you're using asynchronous messaging or queuing or whatever you're going to call it, like some of the area, like if you've used SQL Server Service Broker or you've used MQ series, you've used this pattern, and traditionally this is kind of called a pub sub pattern, and that's used for decoupling, for making synchronous applications asynchronous. So the goal of this is to typically give you better throughput. Like I know Monica's client that does a lot of online transaction processing. Uh,
They do something similar.
yeah, they use this pattern, and not exactly this technology, but this pattern. Uh,
I've always equated this to like service broker in SQL,
yeah, no,
right?
it's
You know,
exactly the same thing.
that
Yeah,
concept is still the same.
yeah. It's just what you use for queuing.
Right, right, right.
Yeah, there's a few different ways you can do queuing in Azure, and queue storage is probably the least functional, but it is a pattern where you can do messaging, and especially when you have a multi-tier complex web app that has a lot of workload, it's a good way to kind of increase your throughput for any kind of inter-process communication. The other part, John, tell me a little bit more about table storage. I'll get the slide queued up for you.
So table storage, and I'm with you. Like I don't see a lot of organizations using queue or table. I see mostly blob and file. And so I've always equated table storage to be similar to like Cosmos, where it's a key valued pair that we store. You can see that we got a couple entities, and those. The trick though is the values can be larger, so it's not just a one-to-one per se. But just like this, you have that unique storage account, storage account name.table.core.windows.net. So that's very similar. If I was using queue, you're gonna have queue there instead of table. But so it's got a couple different things. The highest level is the namespace. You can have multiple tables in there. And each table contains a set of entities, and the tables are scoped to the account. And then the entity, I mentioned multiples, but it can hold up to, I think, 255.
Yeah, 255.
I think that's right. But the combined total size of all those properties in a single entity can't exceed 1 MB. So you do have an upper bound files or property size wise. You can have 255 properties, but they have to in aggregate be less than 1 MB. So again, I don't see a lot of clients using or organizations using table. I don't know if you've got clients using it or not, but
The billing system at a very large client I worked at is that
are they using table storage?
yeah. A large cloud provider. Yeah, they use table storage. Like John mentioned, it's really similar to Cosmos. It's really similar to Cosmos Document DB, but it's
Yeah,
way cheaper.
yeah, and
It's really cheap. In the history of this, we were talking about this before we got started. Before log analytics existed, this was how you did logging in Azure. So like when you enabled logging, it just went into table storage. So that was most of my experience with it. One of the things that's a little bit of a challenge is you basically have to write C# code to like do anything.
And I think it's worth noting, like when we say table, we're not talking like a SQL table. Like
Yeah,
the table concept is very flexible. There's no actual structure to the table. The structure is within the key valued pair itself.
Yeah.
So like, just for there's SQL people watching, it's not a table like we play around with in a database.
It's like a table in Mongo.
Yeah, it's like a table in Mongo. That's what I should have just said.
Yeah. It's not a relational table that inherently has so many columns. So
not relational. Not relational.
Dealing with data that is going to have flexible schema over time.
For sure.
Yeah, this is a little bit of ancient history. These slides were from the training Denny and I did in India in like 2017. So I knew I was like, I had some good slides on this topic, but I couldn't remember. And I was like, yep, 2017. So that's kind of an overview of Azure Storage, kind of talking about it from a developer perspective. We didn't focus on VM storage. If you want to hear more about that, I'll put a card in the video so that you can see that VM storage talk we did a couple weeks ago. So that's there. Anything you want to add about the types of storage and what you should use it for?
No, like I said earlier, I love Azure storage accounts. They are very versatile, especially for like SQL Server backups. I try to get most of my clients because it offers high levels of resiliency as well as disaster recovery. And you know me, I'm very big on disaster recovery, even in the cloud.
I just remember something we didn't talk about Blob storage. We need to add this topic because it's important.
You talking about the
Blob storage account replication? Yeah.
Oh, like zone redundancy and GRS.
Yeah, and I don't know.
I think we have a slide about it.
Yeah, I don't know if you can change it. Let me share my screen. I don't think you can change this after the fact, but I think I can talk to it without.
I think you can. I think that you within limits, like there's certain things you can't go from data lake storage back.
So
I know that.
Important thing to note. This is a locally redundant storage account. If you look at any of my labs, they're all locally redundant because it's the cheapest. Locally redundant means you're in one Azure region in one data center. So zone redundant would mean you're spread across the 3 zones in a region. There's also geo-redundant, which means you're spread across 2 regions in Azure, and we should probably do a talk that's just about regions and how all that stuff works. With Azure Storage, that means you're in the paired region, which like for US East is US West, and there's a whole list of paired regions. Paired regions generally don't matter, but this is one of the places where they do. There's also read access geo-redundant. Which means you can read those without having to fail over. So with standard GRS, you have to fail it over. It used to be that Microsoft had to declare an outage, but you can fail it over manually now. But read access geo-redundant. And those are going to apply to everything under the storage account. So tables, queues, containers, file shares, that all applies. And they each have varying levels of cost. It's basically double LRS to have GRS. It's like 10% more than that to have read access GRS. But yeah, I can't believe we missed that, but that was my fault.
That's a great thing. And I think we can change it. I think that you can, within limit, like you can go from locally redundant to geo redundant and back.
Wait, I found the screen. I was an idiot. Hang on. Let me share again.
I seem to remember.
It's on the redundancy tab. I just missed that. I clicked on the data protection tab. Yeah, so I can.
So you can change it.
Yeah, I can change to zone redundant or read access geo redundant, and you can do geo zone redundant. And the reason why those two are grayed out for me is because East US is paired region is West US. I'm 99% sure.
You're correct.
And West US doesn't have availability zones. So if I made it read access geo zone redundant and not had a headache from trying to say that name, it wouldn't work because my other region doesn't have availability zones.
So I mean, thinking about what redundancy you need for your storage account is probably pretty important to, at least talk through and figure out what you need, depending on what data you're storing. Like if I'm doing development work, I just use LRS because there's a cost to that, right?
Yeah.
There's a cost if I'm doing GRS and I'm replicating that across regions. There's an additional cost for that. You don't get that free. So, making sure that you understand the cost model for that allows you to help pick the right redundancy for your data.
For sure. And if it's something you need for production use, like
Yep.
for backups, make them geo-redundant, but everything else you can keep LRS. And this is all, there are 3 copies of your data in each region. It's complicated. It's the same things we talked about in the other storage episode.
Yep.
Well, thank you for joining us, and we look forward to having you join us for the upcoming networking sessions we're going to do. And like and subscribe, and we'll see you back in a couple weeks.
See ya.